Okay, and the last little set of new terminology that we need to learn about is the idea of Venn diagrams. Hopefully you've seen this before, where you have two things that have something in common and then some things that are not in common. So this circle overlapping another circle is the Venn diagram. Hopefully you've seen this before. It comes up a lot, not just math, just a way of organizing thoughts. And so what would be some colloquial Venn diagram of things? Let's think here. Maybe you have some tools at home, and some of them are electric tools and some of them are just manual tools. But you also have other electronic items. Yeah, this could work. So maybe your cell phone is something that requires electricity, but your drill is a tool that requires electricity. Just like your hammer is a manual device, but it's also a tool. And so what they have in common is that they are tools. And what they don't have in common is that this is electric, and then this is non-electric. I know what some people are going to say, wait, the cell phone is technically a tool, but I mean like specifically like carpentry related. I don't know, maybe cell phone isn't the best the best thing because you could probably classify that as a tool. Let's say like vacuum cleaner. I don't know, I guess anything could be considered a tool, I guess, but you get what I'm saying. There are things that are in common, not in common, but then have like one characteristic that is in common. Okay. And so we're going to start building some notation around the idea of sets, because sometimes we need to look at the things that things have in common as well as the things that they don't have in common so that we can draw some inferences about them. We can make some deductions about them as well. So for the purposes of notation, we'll call this part P and this part Q. It doesn't really matter what they are for now, but for the purposes of notation, if we want to only look at the things that they have in common, we will talk about the intersection P, and it's like, it looks like an upside down U kind of shape. That means intersection. That's the intersection. And because I'm lazy, I will copy and paste. Now, if we want to look at the parts of P and Q, if we want to look at all of P and Q, so this is like when we want to put the two categories together. This is everything together. We just look at the set of all of the objects together. That is the union of P and Q. So that's, again, like these are just, it's the same shape, but one's upside down compared to the other. But this is the union of P and Q, because sometimes we want to look at what happens when we put the sets together. So that's a little bit about Venn diagrams. It's a little bit about sets and some notation stuff. We're going to use this stuff a lot. So come back to this video or even post questions if you have them, and I'll try to give you some other ideas. We could have also spent a little time, might as well just do it now, But when we were talking before about implications about things, it really is this idea P and Q. So this is really what this means, if P then Q. It means that if this happens to be true and P lives inside of Q this way, like Q is dependent on P basically, then P is in the set of things that Q depends on. So we'll talk more about this, but I just wanted to show you visually. I never thought of it this way until I reviewed the text, but you could totally think of it this way, and this would also be correct if P then Q. All right, that concludes section 1.1. It moves a little bit faster than some of my other texts, but we will just continue on in this fashion. Happy learning.